So today what we're going to actually do is I just want to go over a couple things with Lewis dot structures. So hopefully you guys remember the notes and the videos you guys took on, was it Thursday now? Such a long time ago. So hopefully you remember from Thursday, you guys took notes on two different videos. One was Lewis dot structures and one was ions and valence electrons. So Lewis dot structures is one of the things that we're going to be adding on to this table that we've been working with. So the couple new things that we are going to add on are these last three right here. So those last three are the ones that we're going to have to worry about today that are going to be a little bit different from the past. So the first one I want to talk about is the nuclear symbol, just because it's already drawn for us, so we can come up with a few things from that nuclear symbol. Can anybody figure out one of the things that they'd be able to identify based off of this nuclear symbol?
The mass.
The mass. And which number do you think the mass is going to be?
20.
20. All right. So here, this would be mass. I'm just going to draw an arrow. Any other numbers we think we know? Or anything?
The atomic
Positively number? Charged.
It's positively charged. What else did somebody say? I'm sorry.
The atomic number.
The atomic number. What number is the atomic number?
42.
Charge. Atomic number. And there's one other thing we're going to learn from our nuclear symbol. And what's that going to be?
The calcium.
That is calcium. We're going to learn about the element. So this is the element symbol. So the element symbol is the one other thing that we're going to know. So this will be able to pretty much tell us everything from that table, help us identify everything we need to know about this element. There's one thing I'm going to switch on you guys, is that the mass number is going to be that 42 and the atomic number is going to be that 20. And that's going to be the case because our mass number always needs to be bigger than the atomic number or the same number as the atomic number, because remember, the mass is found by getting our protons plus neutrons. So if we had 42 protons, or the atomic number was 42, then our mass number would at least have to be 42 in order for that to work. Plus, if we look at our periodic table, we should see that calcium down here, calcium has an atomic number at the top of 20. So it's going to be flipped. Our mass number and our atomic number for our nuclear symbol are going to be flipped when we look at it from the periodic table. So our mass number is on top here, our mass number is on the bottom on our periodic tables, and our atomic number is on the bottom here, and it's on the top of our periodic tables. And then that charge is going to be important because it's telling us, do you guys remember what that charge tells us about our element?
If we lose protons or electrons from the valence shell.
Awesome. So if we lose just electrons though. So one thing I do want to make a note of is that we can't lose electrons without changing our element. So we can only lose or change the number of neutrons or electrons in our element. If I have calcium, I always have to have 20 protons. So let's start filling out this table, and then we can get to the last column. We'll get to Lewis dot structures, and we'll figure that out in a second. So let's start with element. What element do we have again?
Calcium ion.
Calcium. So we're just going to call it calcium. Oh, if I had a pen, we're going to call it calcium over here. We don't have to include the ion part, but what else do we have to include with that element name? Do you guys remember?
The atomic mass.
The mass number, the atomic mass. And what is our atomic mass?
42.
42. So we're going to put that number right here, 42. And now we have that first column. It's done because we know it's calcium, and it's calcium 42. And then we need the atomic mass number. And remind me, what's that number?
42.
42. Perfect. Not too bad. And can you guys remind me the number of protons? How do we find the number of protons?
The atomic number.
The atomic number. So I'm just going to write above it just to remember. Same as the atomic number. All right, so we know our protons is really the same as our atomic number, and for calcium, it's always what number?
20.
20, perfect. Number of neutrons. How do we find the number of neutrons? Do you guys remember?
Subtract the
the
proton
mass.
from the mass.
Awesome. Heard from a couple people, so we're going to take our mass number minus the number of protons to get our number of neutrons. So in calcium's case, what is our number of neutrons?
22.
22. Awesome. All right. So now is where we're going to get a little bit trickier. Electrons. How many electrons is this calcium going to have?
18.
18.
Awesome. You guys are crushing it. And it has 18. If you were going to guess 20, you're great. You're crushing it, except for in this case, we have that charge of a positive 2, which means that we have to have a +2 charge, or we have to have 2 more protons than electrons. All right. Now is where we get to probably the hardest part of the day, and that's our valence electrons. And that's going to be a couple of issues. So I want to go back to that periodic table, and I want to look at calcium. And just normal calcium on the periodic table, can you guys tell me how many valence electrons calcium will have?
2.
Perfect, 2. And it has 2 because it has 2 electrons in its outermost shell. Or if we look, calcium is the second element in its row, and every row is a new shell or orbital for our elements. So it's the second one, which means it has 2 electrons in its outermost shell. Hopefully you guys remember all of our valence electrons. Do you guys remember the first column, how many valence electrons it's going to have?
1.
1. What about the second column?
2.
2.
2. Do we know how many are in the third?
3.
I heard a 3. What about the fourth column?
4.
4. Fifth,
5.
5,
sixth one,
6,
6.
seventh one,
7,
7.
next one,
8,
8.
next one,
9,
9.
next one.
10.
10.
All right, I see that you're saying it's incorrect. And why are you saying that's incorrect?
Because the furthest we go is 8.
The furthest we go is 8. So what are we going to have to do? What happened?
Subtract 10.
Subtract 10. Okay, so perfect. So these ones actually go above these columns. This section in the middle, those, what is that, 12 columns. So from here all the way to here. You guys even see that highlighter? It's probably, let's try again. These columns from 3 to 12, we're not going to be able to know how many valence electrons, and that's because of something we'll get to a little bit later called our d orbital. These electrons are actually in, when you get to this one right here, so if I start at scandium, what happens is that electron actually goes into its third orbital and not the fourth orbital. So that third orbital will get 10 more electrons, the fourth orbital will get more electrons. So these ones are not going to work for our numbering. So the ones we can tell just based off where they are on the periodic table are going to be just the first 2 columns. We're going to skip everything in the middle, and we're going to go to 13 is going to have 3, 14 will have 4, 15 will have 5, 16 will have 6, 17 will have 7, and 18 will have 8. What element is not going to have 8 in that last column?
Helium.
Helium. You guys are crushing it. Helium only has how many electrons in its outermost shell?
2.
Only has 2, and then that first orbital is full. So now I want to look at calcium's Bohr model. Do you guys remember how to draw the Bohr models? I'm going to start with my protons, neutrons, and electrons for calcium. And I just want to start with neutral calcium, number 42. If it's neutral, how many protons did it have? How many protons?
20.
20, there we go. 20. Calcium 42 had how many neutrons?
22.
22.
22. And if I have a neutral calcium, how many electrons am I going to have?
20.
20.
20, perfect. So if it's neutral, it has 20 because it'll have the same as the protons. If it's not neutral, if it has a positive charge, if it has a positive 2, it has 2 less. So if I'm drawing my Bohr model, what's the first thing that I draw?
The nucleus.
The nucleus. And what goes inside the nucleus?
Protons and neutrons.
Protons and neutrons. So protons is 20, neutrons is 22. And then what do I draw next?
The
First
orbital.
orbital.
The first orbital gets how many?
2.
2. The second orbital gets how many?
8.
8. All right. 4, 5, 6, 7, 8. The next orbital gets how many?
8.
8 again. Wonderful. You guys are crushing it. All right. And then do we need a fourth orbital?
Yeah.
Yes. And how many electrons do I put on that one?
2.
2. Wonderful. 1, 2. Perfect. So that's my neutral calcium. Now, if I told you that I had a positive 2 charged calcium, what is the only thing that's changing?
You're
Electrons.
removing the outermost shell.
You're removing that outermost shell of electrons. Perfect. So right now we know that calcium had 2 valence electrons, and we just removed that. And so then remember we put those brackets around it. We put that +2. And so now we have our calcium with the +2 charge. And now it has 18 electrons instead of 20. So this is where it gets a little tricky with our valence electrons, is because for calcium with a +2 charge, how many valence electrons does this calcium have?
8.
It no longer has 2, but yes, it does have the 8. So when it has that charge, if we're getting those electrons down, now it has 8 valence electrons because of that +2 charge. All right. Any questions so far? All right. So then the Lewis dot structure. If you guys remember, what do I draw in the middle for my Lewis dot structures?
The element symbol.
The element symbol. Perfect. So Ca. And normally, what do I put around my element symbol?
The dots.
The dots. And on a note, if my calcium did not have a charge, how many electrons, how many valence electrons do I put? How many dots do I put?
2.
2.
I put 2. But since this has a charge, what do I do instead? What happens to those 2?
You remove those 2?
You remove those 2. You're giving them away to somebody else, but you're going to remove those 2 electrons. And instead, what you're going to add is that +2 charge. So we're not going to put the 8 on there because we put this +2 charge instead. Are we okay with this? Are there any questions about this?
Do we have to draw a circle around the element symbol, or do we just draw the element symbol by itself?
You can draw the element symbol by itself. If you want to draw the circle, it's fine. It also works, but you do not need the circle.
Okay, thank you.
Yep. Any questions on this one? All right, so then one last thing I do want to talk about is how to place our valence electrons around our element symbols. So I'm actually just going to go to the very bottom of my page just so I have room. And I'm going to go with the element X, not a real element, just a random letter that I want to use for my element. When I'm drawing my Lewis dot structures, we do it in a certain way so that the electrons on the outermost shell come in pairs. And we're going to do this because in the future, when the elements are not paired, that shows us that there needs to be a chemical reaction or a bond so that they can add up to 8, because all elements want to have 8 electrons on their outermost shell. So when we're drawing them, we start with the top. We're going to go with 1. Then we're going to move clockwise around our element so that each one ends up with 2 electrons by the end. So my first one will go on the top, my second one goes over here, my third one will go down here, my fourth electron will go down here, and then we're just going to repeat the cycle again. So my fifth one will go up here, so now there's a pair on top. My sixth one's going to go right here, so now there's 2 pairs, one on the top and one on the right side. My seventh one will go down here, so now we have 3 pairs. And then my last one, my 8th one, is going to go right here to pair up my last side. So we're going to put them around our electron, our element symbol in pairs, but we have to go one at a time because we always want to fill that octet rule somehow. So that's why they get charges. So that's why they lose electrons or gain electrons to get those 8 valence electrons in the end, which is why we have to set them up in pairs to see how many more we need to make, how many more reactions we need. Are we okay with that? Do you guys want to try another one together before I let you guys work on your own?
Sure.
Sure. All right. Do you want to do the next one? Hydrogen? Or do you want to do cesium?
Cesium.
Cesium? All right. Making it harder. All right. So first thing we have to identify cesium on the periodic table. Let's find it. Let me erase all this other stuff that we don't need to see. All right. Where is cesium on the periodic table?
Atomic number 55.
Perfect. Atomic number 55, way down here on the bottom left. All right. So now that we know its atomic number, let's go back to our worksheet. All right. We know its atomic number. So where can I put that 55?
Proton.
Perfect. So I'm going to put my 55 on the protons column. All right. What else do I know right now?
The atomic mass.
The atomic mass, which is?
134.
134. Perfect. 134 right from here. Our mass number. All right. What about neutrons? Do I know the number of neutrons, or can I find the number of neutrons?
79.
Wonderful. 79. And we got that from 134 minus 55. What about the number of electrons?
55.
55. Since we don't know that it has a charge, we're going to assume that this is a neutral atom and that it's going to have the same number of electrons as it has protons. All right. So now number of valence electrons. So we need to look.
1.
Perfect.
One.
It's in that first column. It's in that first column, which means it only has 1 valence electron or 1 electron on its outermost orbital or shell. So we're going to put 1 valence electron. All right, the nuclear symbol. What do I put in the middle of my nuclear symbol?
CS.
CS for cesium. What goes in the top left?
The atomic mass.
The atomic mass. So I'm going to put 134. What goes in the bottom left?
Atomic number.
Atomic number. So I'm going to put 55. What goes in the bottom right?
The charge.
The bottom right or the top right?
I don't know.
Top right.
The
Top
top
right.
right is where the charge goes. So what am I going to put there? What's my charge?
0.
0. So I'm not going to put a charge on there if it's 0. So I'm just going to leave it blank. And then what goes in the bottom right?
Nothing.
Nothing. That's right. I'm just being mean. All right. And then my Lewis dot structure. How do I draw that again?
CS in the middle.
CS in the middle. How
And
many?
then 1 dot on the top.
1 dot on the top. Perfect. Are there any questions on what you guys should be doing? Do you guys think you can do the rest?